Okay, so here's our topic for today, motion of objects in two dimension or projectile motion. Projectile motion, it is an object that is thrown in a curved path with the effect of gravitational field involves motion in two dimensions. This motion is called the projectile motion, where the object that was thrown is called the projectile, while its path is called the trajectory. So the projectile is the object that is being thrown, and the curved path we can see of that projectile projectile is what we call the trajectory. And the highest point I forgot to include here, you may take note while listening, the highest point wherein a projectile can reach is what we call the apex. Apex or APEX. That's what we call apex. The highest or the maximum height of a projectile is what we call apex. In dealing with projectile motion, if we're going to solve problems here, we can make use of these equations. But first we have to take note of following. Vx and Vy, or the components of the velocity along the x and y axis, is involved in here because the object is traveling on a curved path. That means there is a direction, that means it is a vector. Velocity is always a vector, therefore there is, since the object is moving horizontally at the same time it's moving vertically, the object has component along the x and y axis. So our application here of components of vector quantities is very important. So please recall our topic before about vector component of vectors, how we solve for the vector. So we can apply that here. And here are the kinematic equations for projectile motion, but we have to take note y is positive upward and a sub x is equal to 0. A is the acceleration due to gravity along the x-axis, but there is no gravity moving, or there's no gravity pulling horizontally. That's why it's always 0. So take note of that, it is constant. A sub x is 0. A sub y, since our gravity here is pulling or acting on objects vertically, therefore we have a sub y, which is negative g, or the negative 9.8 meter per second squared. So for horizontal motion, we have to take note that ax is equal to 0, bx is constant. So we can make use of these equations. And vertical motion, for the vertical motion of objects, here in projectile motion, ay is always negative 9.8 meter per second squared. Here we can make use of these equations. Y is the vertical distance, v sub y and v sub 0, that's the final velocity and the initial velocity, gravity, and time. So we can make use of these equations in dealing projectile motion problems. So for example, number 1, a movie stunt driver on a motorcycle speeds horizontally off a 50-meter high cliff. How fast must the motorcycle leave the cliff top if it is to land on level ground below, 90 meters from the base of the cliff where the cameras are? So, as you can see in the figure, we have the given height of the cliff and the base, the horizontal distance from the cliff and to the cameras. So we are to solve for its initial velocity. We always take note that ax is 0, y sub 0 is also 0. So the following, as you can see here on the given equation, we can make use of these two equations. First, okay, so sorry for this. I am honestly having a hard time and managing my time because I'm currently having health issues, maybe because of the stress and anxiety we are experiencing right now because of this pandemic. But it may sound just an excuse, but it's true. Kaya nga pumayat si mudra nyo. Okay, so now going back, here's the solution. Just captured it using my phone. So first we have to solve for the time, and solving for the time we can make use of this equation, since we know that y sub 0 and by sub 0 becomes 0. These two becomes 0. So what's left here is y is equal to negative 1 half gt squared. And now we have here 2y gt squared. Take note that for most of the time this becomes positive, or maybe it's positive, really positive here. But always remember we have no negative distance, so it should be positive unless we are solving for the velocity or time, or I mean the velocity, since if we're going to solve for velocity it may be negative or positive. So here there's no negative time, so it's let us disregard this negative sign here. It's positive, so t squared, solving for time here, this becomes t squared is equal to 2y over g. Time is equal to, so square root, to eliminate these two here, we have to introduce square roots on both sides of the equation, so t squared is equal to square root of 2y over g. Nawala na yung square dito since nalagay natin ng square root. So square root of 2, the given y is 50 meters divided by the constant acceleration due to gravity, which is 9.8 meter per second squared. So the resulting time is 3.19 seconds. We have to solve for time because though it wasn't required on the problem, but because we are using this equation and we have no time given, so we have to solve for it. That's why we solve for time, and the result is 3.19 seconds. So our initial velocity now is x over t, distance over time, which is 90 meters, the base, divided by the 3.19 seconds. The answer is 28.2 meter per second, the initial velocity of the movie stunt driver. Okay, so that's it. Second example, a tiger leaps horizontally from a 7.5 meter high rock with a speed of a from the base of the rock will she land? Here's the solution. Kayo na maghanap ng given, kayo na rin dun sa what is required na problem. I'll leave it to you. Here's the solution. Again, for solving time, we often use this one. If there's no given initial distance and initial velocity. But for most of the time, for most problems in projectile, mag-zero talaga yung dalawa. So you can just directly use this equation. Y is equal to 1 half gt squared. Solving further, we have time is equal to 1.24 seconds. So we can solve for the base or the horizontal distance. The horizontal distance is now, using this equation, we have 4.5 meter per second times the time, which is 1.24 seconds. So the answer is 5.57 meters. Okay, next. Diver running 1.6 meter per second. So meron na siyang initial velocity and reaches the water below 3 seconds later. That's the time. How high was the cliff? Okay, so we have there, that's the solution. Meron 3 seconds na time na given and the 1.6 meter per second initial velocity. So solving for y, we can use this one. Y is equal to 1 half gt squared, constant g, 900 meter per second squared, and the given time, 3 seconds. So we have total of 44.1 meter as the vertical distance of the cliff. And solving for the x, 1.6 meter per second times the time given 3 seconds. So we have 4.8 meters. That's it. Very easy. As long as wala yung curved, walang direction na binigay or walang angle na binigay. Kapag meron ng angle na binigay, this will all become different. But I won't give you an example of that. You may research because I'm not going to give you any quiz related to those kind para hindi na kayo mahirapan. Since I know that this will be very difficult. Wala tayo sa face-to-face, so talagang mahirap talaga siya. And last example, a ball is thrown horizontally from the roof of a building 56-meter tall and lands 45 meters from the base. What was the ball's initial speed? Here's the solution. From this equation, this one, since mag-zero ito, so we have to solve for v, or the velocity. So x over t, we have no time given in the problem, so we have to solve for time again. So using this equation again, our time here is 3.4 seconds. So substitute this time here. So 45 divided by 3.4 seconds, the resulting initial velocity is 13.24 meter per second. Okay, so that's all. Thank you for listening.
I never made it, but I